So let's look at the problem statement first. You are given an array and you have to make the array a good array. So what is the definition of a good array? So the definition is for every pair I comma j maximum of ai comma aj modulo minimum of ai comma aj should be equals to 0. This is the definition of a good array. And in this array you can do at most n operations. So what is an operation? The operation is you have to choose an AI and change that AI to AI plus X, where X is a positive integer and X must be less than is equals to AI. So you can do this operation at most n times, and after doing this operation you have to make the array a good array. So this is the problem statement. Now let's move to the solution. So what we need an array such that maximum of ai comma aj modulo minimum of ai comma aj should be equals to 0. So if we just sort the array, let's say after sorting the array looks like this. So if this condition wants to be true, this an should be a multiple of all the elements before an, right? So all the elements before n should divide an, right? Again, this an minus 1 should be a multiple of all the elements before an minus 1, right? Again, we can say that this a3 should be a multiple of all the elements before a3. So if we just sort the array, we can say that every ai should be a multiple of all the elements before ai. If we sort, then we can say every ai should be a multiple of all ai before ai, right? So every ai should be a multiple of all ai before this ai, right? So this can be our first observation. Let's move to the second observation. Let's take the array, sorted array, that after sorting the array looks like this. So in the first observation we have seen that every ai should be multiple of all the ai before this ai, right? So if I just say that a2 a multiple of a1, suppose a2 a multiple of a1 and a3 a multiple of a2, right? So we can say that a2 a multiple of a1 and this a3 a multiple of a2. Now see, as A3 a multiple of A2 and A2 a multiple of A1, which makes A3 also a multiple of A1, right? Because A3 a multiple of A2, but A2 is a multiple of A1, which is to say A3 will also be a multiple of A1. If there is another element here, suppose A4, and we say that this A4 is a multiple of A3, then this A4 will automatically be a multiple of A1, A2 and A3. Why? Because A4 is a multiple of A3, but A3 is a multiple of A1, A2. So A4 is automatically a multiple of A2. Again, A3 is a multiple of A1, so A4 will automatically be a multiple of A1. So from this observation, we can say that if every AI is a multiple of AI minus 1, that means every AI is a multiple of all AI before AI, right? So if every AI is a multiple of AI minus 1, then our first condition will be true, right? So this is our second observation. Now let's move to the third observation. Here we will propose that suppose there are two integers b and a, right? And b is greater than a, and b mod a not is equals to 0. Suppose there are two integers b and a, and b mod a not is equals to 0 and b is less than a. Then we can make b mod a is equals to 0 by simply adding x with b where x is less than is equals to b. Let's not call this b, let's call this b plus x. Let's call this b plus x, right? Suppose b is greater than a and b mod a not equals to 0. Then we will add an x with b, and this b plus x will be a mod of a, but this x will be less than b, right? That's what we are saying. So why this is true? Let's see that. So what are the multiples of a? The multiples of a are a, 2a, 3a, na, n plus 1a, right? So after every a interval there is a multiple of a, right? So after every a interval there is a multiple of a, and now we are saying that b is not a multiple of a, right? So b lies somewhere between b can lie here, here, anywhere. So let's say that our b lies here, right? So this is our b. So if b wants to be a multiple of a by adding some x and x is positive, then the x is actually this, right? This is the x required so that b becomes a multiple of a, and we can say that x will be less than a, right? So x is less than a and a is less than b. As we have said earlier that b is greater than a, so we can say that a is less than b. So we can obviously say that x will be also less than b. So we can say that we can make b plus x mod a equals to 0 by simply adding this x, positive x, where x will be less than b. So this condition is, so this whole thing is true, right? So if some b is greater than a and that b mod a is not equals to 0, we can add an x with that b and it will be a multiple of a where x is less than b. This is true, right? So let's go to the final part. So suppose after sorting, the array looks like this. So in the second observation, we have seen that every AI should be multiple of AI minus 1, right? So this thing should be true. So first let's make this A2 a multiple of A1. So as we have sorted, A2 will be greater than A1. Now let's say that A2 is not a multiple of A1. Now how we can make A2 a multiple of A1? By adding multiple of A1. In the third observation, in the third observation, we can map, see how the mapping is going on. We can map B as A2 and A as A1, right? In the third observation, we have seen that there are two numbers, B and A, and B is greater than A, and B mod A not equals to 0. This is the same here. We can say that this A2 is actually B, and this A1 is actually A, and A2 mod A, A1 not is equal to 0. So we can make A2 mod A1 is equal to 0 by simply adding X, and X will be less than this A2, right? According to the third observation. So let's say after making this, the array looks like this. So now we have added X to A2. So A2 will be like this, right? Okay, so let's call this D. So A2 is a multiple of A1. Now we have to make A3 a multiple of A2, because if A3 a multiple of A2, as A2 is a multiple of A1, A3 will be automatically a multiple of A1. So our task is to make A3 a multiple of A2, right? But it is not A2 now, it is A2 plus X because it has been changed. Now three things can happen. First thing is, after adding X to A2, that A2 plus X can be bigger than A3, right? Why? Previously A3 was bigger than A2, but after we have added an X, this A2 plus X can be bigger than A3. This can be a case, right? This is our case 1. So this is our case 1. So A2 plus X can be bigger than A3, right? So we can say that D is greater than A3. So we have to make A3 a multiple of A2. So we can make A3 a multiple of A2, right? By simply making A3 to D. So if we make A3 to D, then this A3 will be a multiple of A2 plus X, right? So we can add D minus A3. If we add D minus A3 with this A3, right, then this A3 will be D, right? And if A3 becomes D, it is a multiple of the previous element, right? So our condition gets true. And so we have to add this. The second case that happens, that even after adding, A3 remains bigger. This can happen. If this happens, then we will again the third observation, let this A3 be B and let this A2 plus X be A, as B is greater than A and B mod A not equals to 0, right? So we can make this A3 a multiple of this A2 plus X by simply adding some X which is less than equals to A3, right? So if A3 remains bigger, we can make this A3 some multiple of A2 plus X. Let's call this D1, right? So this can happen. And the third case is if A3 is equals to A2 plus X. In this case, we have to do no operation because a3 is already a multiple of a2 plus x. So we have to do no operation here. So there may be some confusion here that while adding d minus a3 to a3, are we violating the constraint of x being less than ai? It is not violating here because if we just see this, you will be understand that suppose this is our number line and this is our a2, and we have added x with this a2, and thus this a2 becomes d, right? So we have previously seen that x is less than a2, right? And a3 is already bigger than a2, right? So so if we add x with, so x will be less than a3 too, right? As a3 is greater than a2, a3 is greater than a2, x is less than a2, so x will be obviously less than a3, right? But we are not adding x even, right? We are adding less than x, right? So if x is already greater than a3, so something which is less than x, which will be eventually less than a3 too, right? So if we are adding this d minus a3, this will be always less than a3, right? So by doing this, we can make every ai a multiple of ai minus 1, right? So if we can make this, the array will be good. Now the question may rise that how we can find the x. It is very simple. So how to find x? So suppose this is the number line, so the multiples of a are a, 2a, 3a, na, n plus 1 a, dot 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 goes on, right? So suppose b is here. So we have to find these x, right? So if we just write that v is equal to b integer division a, we will find this point, right? And this point will be, suppose let's call this d. This d will be b plus 1 into a, and our x will be this d minus b. So that's how we can find out the x, right? So this is the solution here. If you have any doubts or any questions, feel free to ask in the comments, and please subscribe to my channel. Thank you.